Everything might not always turn out great when you're dealing with rationals. Sometimes you will get a situation where you're trying to divide by 0, and that's what we're going to look at in this video. So what happens if the denominator would be equal to 0 when you try to plug in that number? In order to see what we're going to do, we're going to look at these two different graphs. So one is x minus 1 over x squared minus 1. This is our red one. And our blue one is 1 over x plus 1. So if you look at these two graphs, hopefully you notice that they look really, really similar. They basically are exactly the same. The only place they're not the same is right here, right here. One of them has a little open dot and one of them doesn't. And why is that open dot there? If I were to take this rational and factor the bottom, we can see that the x minus 1 factors would cancel. And this is equal to 1 over x plus 1, which is the exact function we have up there. So it turns out the only difference between these two rationals is we're able to cancel out a factor, and that cancel out factor causes this hole in the graph there. But if you look at this graph in terms of not the actual function values, but the limits, absolutely nothing's going to change with the limits, because we know this, even though there's a hole here, the limit will be that number itself, which is what, 1/2. So it doesn't matter in terms of limits, which one we're actually looking at. We could be looking at the red graph or the blue graph. All the limits are going to be exactly the same. So our basic goal when we're dealing with rationals is, if we can simplify, we simplify and cancel out terms like we did here, and then we try to plug in that number. Because the limits are going to be the same, we might as well work with the simpler expression. That's exactly what I said. Factor the top and the bottom, cancel out any common terms, and then try to plug in the number. So this one, if I try to plug in 3, let me just write it over here. We have 2 times 9 minus 5 times 3 minus 3. Let's see, 18 minus 15 minus 3, and that's 0. So if I try to, from the start, plug in 3, I would get 0 on the bottom, and that's bad. Just in my hint that I should try to factor this. So this is going to be, on the top, I can factor out an x. On the bottom, let's see, I want to get negative 3 when I multiply, and negative 3 there, plus 1 there. Let's see, double check that I factored right. 2x squared, x, negative 6x is negative 5, negative 3, yep. So when I factor these quadratics, and this might be something you have to practice more on your own, is factoring quadratics. This is like the major part of simplifying your rational expressions. When I factor it, I can see there's an x minus 3 on the top and an x minus 3 on the bottom, so I cancel those out, and those are going to be the same as the limit of x over 2x plus 1. And now that I canceled out a factor, now I try to plug in 3. And I get my answer for my limit. So this is a general strategy. If you're trying to take a limit for a rational, step 1, try to plug in the number. If you can plug it in, you'll get your answer. If you can't plug it in, factor it, and then try. So we'll do one more example like that. And if I try to plug in negative 3, I'd get 0 on the bottom. So that tells me I should try to factor it. On the top, I want to add to 4 and multiply. Oops. Multiply to 1. So it gives me this. On the bottom, it's a difference of perfect squares. And factor out, in this case, I can cancel out the x plus 3's. And now that I canceled out that factor, I can hopefully plug in my number, and everything should work. That's negative 2 over negative 6, which is positive 1/3. All right, so this is all stuff you've done before in algebra and pre-calc. You've factored before, you've canceled out values, you've plugged in numbers. All right, the only thing now we're doing it in the kind of interest of determining a limit. All right, so you just know that if you want to find this limit and it doesn't work out the first time, all right, factor and cancel things out.